All right, guys. So today we're going to look at a sample data set. Okay. So in these data sets, we did an experiment, and the experiment we are giving treatment for different types of treatments. We are giving a drug called BCK. Okay. So we have treatment type 1 called BCKA. The second treatment is BCKB, and the third one is BCKC, and then the fourth one is the placebo or the control group. Okay, that's BCKD, that's the control group. Okay, so now the effect that we're looking at here is the effect on the blood sugar level. Okay, so and after administering these drugs, these are the values that we got. Okay, so I'm going to show you how do we input this data into SPSS in the first place. So we have these data sets. Let's say you have finished your data analysis. Okay, and then you have the data set here. Okay, so let me put this in Excel. Okay, so this is the data set that you have. And remember, this is an experiment that you have conducted. So you have 4 groups of individuals. Thus, you gave 4 different types of drugs. Okay, so now, if you are conducting this kind of experiment, I would like you to arrange your data in this format. Okay, so arrange it in an orderly format. So like my own, I started with the control groups first. So there are 6 individuals here that we are giving placebo. Okay, then another 6 individuals we are giving this drug BCKA. Another 6 individuals we are giving BCKB, and then another 6 individuals we are giving BCKC. So it's supposed to be just 24. Okay, they are equal groups, so this one is not there. Okay, so now when you arrange your data in this format, now you are going to assign a value. Just right click on this B here, right click here, then click on insert. So that inserts a new column. Okay, so let's say for our control group, we want to code our control group as what? 1. Okay, all our control groups, we want to give them the value of 1 because they are control groups. Now for the first group, for the second group, I want to give them a value of 2. While for the third group, we want to give them a value of 3. And then for the fourth group, we want to give them a value of 4. Okay, so now we have assigned these values and we have the effects here. So now I'm going to take these numbers here and then input them into SPSS. Remember, we've already prepared our data. So this is how your data should be structured. In this way, make sure that they're all in the same column and they are organized by groups. Okay, so now remember that this represents our blood sugar, which is the outcome. We want to look at the outcome of these medications given on the blood, on the sugar, or yeah, on the blood sugar, blood glucose level. Okay, so that's what we're looking at, and these are the numbers assigned to our group. So now we have converted these into numbers. Now I'm gonna just copy this one here. Just copy it, Ctrl C, come to your SPSS. So these are new SPSS here. So now go to data view, just paste them here. Okay. Okay, remember we're dealing with numbers, not letters. Okay. Now, so that is this one. Remember, it's showing variable 001. We will change it later. Now we go to the next one. The next one is the outcome variable, which is the blood glucose level. We copy everything again. So what I did was to just click on where I want to start with my arrow key, then hold down Control and Shift, and then press the down arrow key. So that gives me a highlight of the range. So I'll press Ctrl C, and then I'm going to come back to my SPSS again for the second variable. So for the second variable, I'm going to come here and then paste it. Okay. All right. So now we have pasted the values. Remember, that is the data view. This is the data view here. Okay. So now we are going to now name. Remember, now it is still variable 001 and variable 002. So we're going to come to the variable view to rename all that. Okay. So this one here represents the first column. 2 represents the second column. So each of these is a column. So this is first column, second column, third column in the variable view. So now I've clicked the variable view. Now I say that the first thing we had here was what? Medication. Okay, medication given. And then the second one was what? The blood glucose level. Okay, so now this first column here is a name. You cannot start with you cannot start with a space. It doesn't allow space in them. Okay, so it is unique, so that's why it's called name. So now I can separate this with underscore or any symbol of my choice. Okay, so now this is blood glucose level. Okay, and medication given. Okay, so remember, I'm not using any space here. Okay, now label is where you just type in what the question is all about. Okay, the question. So question number 1 says what medication was given. Okay, and then what was the blood glucose level after 12 hours. So this is just one of the questions in our questionnaire. All right. Now we have talked about the name column. We've talked about the label column. We're going to talk about this here. This type. So the medication given. What type of data is this? This is a number. Okay. But like we discussed before, there are only 4 values in this number. Okay. So that means you have 4 groups. So even though this is a numeric number, we are using a numeric number just to aid our analysis. But in the real sense, this represents 4 groups of medications. So this is a categorical variable. Okay. So even though we are leaving this as numeric, when you come to the measure here, you are going to select that this is a nominal variable because it is nominal means it is categorical, it has categories. Okay, now under the values, you're going to now define the values. So now I've clicked on these values and then this box opens. So I said our value 1. What is the name of the first drug that we gave? We started with the control group, right? In our Excel, we started with the control group. The way we organized our data, BCKD, control, came first. So the control group came first. So I'll quickly go to my SPSS. So BCKD, that's a control group. Okay, control group. So that's my group 1. And then number 2 is BCKA. That's the first, that's the second category. Number 3 is BCKB. And then number 4 is BCKC. Add. And then you click on OK. So you can see that, so there are 4 groups, and that's why this is nominal. But remember, what we are using to hold these variables is a number, so that's why this is numeric. Now, but when it comes to blood glucose level, blood glucose level has, these are real numbers. It has decimals even. So you still leave this as numeric, okay? And then for the values, you just leave it empty. So it's not a categorical variable. So you tell SPSS that this is what a scale. Okay. So that is how you set your data. All right. So once we have done this, then we are ready for data analysis. Okay. So in the last video, we talked about ANOVA. ANOVA is used to compare more than 2 groups. And the outcome variable in ANOVA is always numeric. So we're comparing the average across different groups. Okay. Assuming that we had only 2 groups, we can use independent sample t-test. Okay. But because we have more than 2 groups, then that's why we're using ANOVA this time around. And ANOVA is part of the general linear model. Remember that. Okay, so you will not see ANOVA is part of it. You can do ANOVA here. It's part of the general linear model, and you can also see it here too. Okay, one-way ANOVA. All right. So, but take note that general linear model, you can use it to do a lot of things. It's more expanded. Okay, so now we are ready to do our test. So first of all, we need to just check for our assumptions. Okay, so this is data that I just created by myself. Okay, so there are assumptions. There are different assumptions of ANOVA. So the first assumption is that your data has to be what's normally distributed. So this is your dependent variable. It has to be normally distributed. So we're going to just check that. So I can just use graph. Okay, I can click on chart builder, click on OK. And then I want just a histogram. Okay. So I clicked on this and then click on this histogram. You can double click on it. So it comes here. So it's not asking me what do I want to put on the x-axis. I just want to put blood. So I'll click on this blood, this variable here, drag it, hold down my left mouse key, and then drag it into here. So now can you see that it seems to me that my data is not normally distributed. Okay, so if I click on this icon, this checkbox here, I'll add a normal curve. So let me see. Okay, so then click on OK. So from here is seeming like, okay, it's seeming like my data is okay, is almost there, but this is just for practice purposes. Okay, so normally ANOVA, your data should be at least fairly distributed. Like it has to follow the shape of the normal curve. Okay, so and that test I can do to check for normality. Can go to analyze descriptive statistics. Just click on PP plots. So I want to look at the blood. Okay, so the distribution I'm looking at here is normal distribution. Okay, and then I'll click on OK. So okay, so like you can see, so it seems like a bit that my data is normally distributed. So we just manage it like that. So you can see that everything, they are all within, they are very close to the diagonal line. Okay, so that gives me another confirmation that this is normally distributed. Now, if I also look at the distributed PP plots, the distribution across both sides of the zero line, see that it seems fairly equally distributed. Okay, so that also gives me another confirmation that okay, part of the assumptions of ANOVA is so part of the assumptions are met. All right, so having confirmed that, I'm going to now do my ANOVA. All right, so now for me to do my ANOVA, click on Analyze, go to Compare Means, go to One-Way ANOVA. Dependent variable is always the outcome variable. Click on this blood, and then click on this small arrow here. Click on the medications. Okay, now and then click on the arrow to put it inside the factor. All right, okay, so here just leave it the way it is. We are not doing a post hoc test at this point because we don't know whether our model is significant or not, so just leave it. Then options, okay, we can get a descriptive statistics. One of the assumptions of ANOVA is homogeneity of variances. Okay, so we're going to click that. And then you can click on means plot. Click on continue. And that is it. Okay, so now what is the hypothesis of our ANOVA? The hypothesis of ANOVA is saying that there is no significant difference in the means of all the groups. So that means that the means of all the groups are the same. Okay, that's our null hypothesis, right? So now these are the means for the control group 5. The mean blood sugar level for the control group is 5.965. For group A is 6.24. For group B is 6.16. Group C, drug A, BCKA is 6.24. BCKB is 6.16. And BCKC is 6.04. Now, our test of homogeneity of variance, that is our Levin test, is not significant. Okay, and that is a good sign. That shows that the distribution, that the second criteria for ANOVA is also met. The Levin test is not significant. Okay, so we are assuming that the variances are the same for across the groups. So now we want to look at what the overall model. So the p-value, that's the C, the p-value for this model is 0.979. So it's above 0.05. So it means that there is no significant difference in means across all in the mean blood glucose level across all the 4 groups. Okay, so that's what it means. All right, so that tells us that there is no, the different drugs, there is no significant difference in blood glucose reduction across all the across the various groups of drugs. So now these are the means plot. So you can see that this is our placebo here. This is the mean, 5 points. Let's see, what's the mean for the placebo group? The mean for the placebo group is 5.96. So you can see that the placebo medication, the placebo, whatever I've used as a placebo, had the lowest reduction in blood pressure. Sorry, the lowest reduction in blood glucose level. Okay, so this is just like a plot of the means to show us which drug is more effective. Okay, so you can see from this our research here, our ANOVA is not significant. So if our ANOVA is not significant, then we stop there. We don't do a post hoc test. All right. So, but then assuming that our ANOVA was significant, that tells us that there is a significant difference in the means across the 4 groups. Then we will likely do a post hoc test. And one of the favorite tests, one of the common tests that you can do is the Turkey test. Basically, because you want to know which groups have different significant mean reduction in blood sugar level. So, and to do that post hoc test is still the same place that we went before. Go to one-way ANOVA, move in your variables as before, click on post hoc. Now you can do Bonferroni or LSD or Turkey. So I can just I'll just choose one of them and then click on continue and then click OK. Okay, so that's basically how to do a post hoc test. And the post hoc test is going to compare. Remember, I'm not supposed to do it here, okay, because my ANOVA is not significant. All right, but assuming it was significant, then I want to know where exactly are the differences between which group and which group. So the post hoc Turkey test is essentially doing multiple comparisons across the 2 groups. So this is comparing the controlled medication to BCKA. All right, so now you can see this is the main difference. How did we arrive at the main difference? The mean for the control minus the mean for the controlled drug BCKD minus the mean for the controlled drug BCKA is minus 2833 minus 0.28333. So Now this is a negative sign. So from simple mathematics, if this one minus this one is a negative sign, so that means that what our our control group, the mean for our control group is lower. Okay, so it has we have a lower blood glucose level in the control compared to um, compared to those that received BCKA medication. And this difference here is not significant. That's what we're seeing here. Okay, so we'll just check, we'll just compare all of them. So looking at the control versus B, also the control drug and BCKB is also not significant. Control versus BCKC is also not significant. Okay, so here in this study, they all have negative signs. So that means that the blood sugar level was lower in the control group compared to all these other drugs, all these other medications. Okay, so basically, assuming that our ANOVA model was significant, we would have seen one that is significant. So can you see here that all of them, they are not significant? None. So that's why it's not good to do a post-hoc test when the ANOVA is not significant, because you must still find anything. All right. Okay. So that is basically that for ANOVA. All right. So that is basically that for ANOVA. Okay. So we see how our means plot again. So now I'm going to just clear everything here. And let's look at another way that you can also do ANOVA again using the general linear model. And that's my favorite. Go to analyze, go to general linear model, go to univariate. As simple as that. Your dependent variable, that's the outcome, is the blood sugar level. Click on it and move it here. Now, your medication is a variable that has groups, categorical variables. So for categorical variables, categorical variables that are predictors, you put them under fixed factors. Assuming we have a variable like age now, which is just a number, it's not categorical. It's not categorical, it's just numerical. So we put that as a covariate here. So fixed factors is for categorical variables, while covariate is for numerical variables. All right. So the model, just leave it as full factorial. Okay, so contrast, we are not doing any contrast at this point. Plots, okay, nothing here, we're not doing anything here. We're not doing a post, assuming that you want to do post-hoc test, you can add it, but we're not doing it here. Okay, so there are different post-hoc tests, like you say. So you can see that's still the same thing, but I'm going to just tell you the difference. Basically, I can just do it and just select our talk test here. Okay, and then I'm going to save the standardized residuals and the unstandardized predicted values. I will tell you why. All right, so, and display the means for both. Yeah, I want the means. Okay, and then I want the effect size. So, and the discrepancy statistics. So can you see that the general linear model is more in-depth? Okay, it's more flexible model. Okay, so here, so you have a this is telling us we have equal groups of 6666 individuals. Okay, now this is also telling us the mean and standard deviation, the mean blood glucose level after 12 hours. Now can you see that we still have the same value? Our overall model is not significant, 0.97. So our R squared is showing 0.009. So that tells us that only 0.009 is how many percent now? I think only 0.9%. of the variance in the in blood sugar level is explained by the independent variable. So the model is not significant. So that's what our R squared is telling us. Okay. I just converted this 0.009 percentage, and that's 0.9%. So you see that only 0.9% of variation in the outcome variable, that's the dependent variable, is explained by the independent variable. Okay. So, and then, so we can see we are still getting the same values here. Okay. So the general linear model is a more flexible, is a more flexible model. Yeah, you can use it to do ANOVA, and use it to do t-test, and you can even use it to test for interactions. Okay, which ANOVA alone cannot do. All right, so these are the two ways of doing that. So I was talking about saving predicted and the predictors, so, and the Z residuals, the standardized residuals. So if we go straight to our data set, remember we asked it to save our predicted variables and the standardized residuals, right? So we can, so now we can actually look at the how to check if our Z simply means standardized. So we want to check if this our standardized residual is also normally distributed again. The same thing again we did before. Go to graphs, go to chart builder, go to here. So now I'm going to just remove this. Then I'm going to click on okay, I'm going to click on histogram again. Okay, histogram is already here. Look at our standardized residuals. How are they distributed? Okay, display normal curve. Okay, so you see, I still get, yeah. So you can see it's also showing that it's a little bit distributed, you know, partially. So don't mind, this is just a random data. Okay. All right, so basically not perfect though. Okay, so then if I also plot the I want to remove this. If I use a scatter plot here, remove take this one, simple scatter plot here, double click on it, and then drag my standardized residuals here, and then drag my predicted values here. I want to see what does it look like now. Okay, so if I add a straight line in between, let me see, I add a straight line because they are standardized. So if I add a straight line at 0, okay, this is my standardized residuals, okay, and you see that the middle number here is 0. Okay, so the mean of when you standardize something, the mean becomes 0. So it's on the x-axis. So I'm gonna just put a line here at 0. So so can you see that the data is equally distributed across both lines? So that also tells me, okay, that my data is normally distributed. Okay, as a confirmation again. All right, so this is basically ANOVA, and that we have covered now. All right, so thank you so much for watching. Please like and subscribe to my channel, and also share it to anybody that you think this might be of help. All right, okay.